morning, my name is Germán Moltó. I'm professor at Universitat Politècnica de València in Spain, and in this video I'm going to cover the AI-SPRINT Runtime Tools as part of the AI-SPRINT framework. Now, there are several user profiles involved in the AI-SPRINT Runtime environment. First, we have the infrastructure provider and sysops, who provisions the computing and data storage infrastructure. And we're using for that both physical and virtualized infrastructure based on cloud computing. Then we have the application and service provider, who provides operational requirements for use cases. Then we have the application architect or manager, who defines the architectural elements of the AI application and who optimizes the application configuration. By the way, this application configuration can be dynamically changed at runtime, as we will see later. Finally, we have the end user, who collects the data and prepares the dataset, who uses also the platform to execute the application to perform inference along the cloud computing continuum. Now, if we focus on the AI application execution runtime workflow as part of the general workflow of an AI-SPRINT application, we'll see that we have first the virtual infrastructure descriptions, which are using the Tosca standard language to describe the cloud application architecture. We also have the AI application components and requirements. And once we have both things defined, then it's time for the AI-SPRINT runtime environment to act. First, we have the automated deployment and configuration of computing and storage. And then on top of this provision infrastructure, then we have the service provisioning and application deployment. Finally, we have the application runtime management and system reconfiguration, which takes care of managing the execution of the application at runtime. Now let's take a look at the main components involved in the AI-SPRINT runtime environment. Now you'll see at the bottom part of the figure that we have several cloud providers. We're using European cloud providers such as Cloud and Heat, and also other commercial cloud providers such as AWS, Google Cloud, Microsoft Azure, and also federated clouds such as EGI Federated Cloud. On top of them, we are provisioning virtual machines using the infrastructure manager, which provides the ability to deploy virtualized infrastructure and to configure these virtual machines to a specific infrastructure, to a specific set of requirements, On top of these virtual machines, we deploy Kubernetes clusters, and these Kubernetes clusters provide the container orchestration platform required to execute the Docker containers on which the AI models are prepackaged. Now, to run these AI models on the computing continuums, we rely on OSCAR. This is a serverless platform that provides event-driven, data-driven execution of applications that can run on Kubernetes clusters that are elastically scalable on top of the underlying cloud infrastructure. And we can run OSCAR clusters on the edge using low-power devices such as clusters of Raspberry Pis. But also we can run OSCAR clusters on a public cloud provider. We can also delegate into public functions as a service offerings such as AWS Lambda, thanks to the use of SCAR, which provides the ability to run Docker-based applications on AWS Lambda with automated delegation into AWS Batch. We are also integrating these developments with PyComs, and PyComs provides the ability to exploit parallelism within the running containers in order to take advantage of the multiple virtual CPUs and to accelerate the executions of both inference and training jobs. We're also relying on SCOAN as part of the AI-SPRINT security framework, which provides trusted computing and the ability to encrypt in-memory secrets so that you can have access to these secrets, even if you have physical access to this machine. We also have the AI-SPRINT monitoring subsystem, which provides the ability to gather infrastructure metrics from the Kubernetes cluster to provide log extraction and ingestion into InfluxDB for facilitate the querying of these logs. And it also provides the ability to synchronize several InfluxDB in a hierarchical manner so that you can have InfluxDB instance at the edge and another one at the public cloud, and you can synchronize them. We also have Krake, which is an open source development by Cloud and Heat, which provides the ability to migrate Docker containers, stateful applications based on Docker containers from one cloud site to another cloud site for latency requirements or for energy requirements. And we are using this to migrate long-running training jobs for AI model training. We also have the GPU scheduler. The GPU scheduler provides the ability to allocate training jobs to minimize energy or execution costs involving the usage of GPUs while meeting deadline constraints. We have a space for AI-R. This component provides the ability to change the allocate the resources at runtime depending on the current load, and in case of performance constraint violations, which are detected by the monitoring subsystem, it can evaluate these resources and it can update the configuration of the running applications accordingly. We also have the privacy-preserving components. These are tools that take into account the trade of accuracy and resilience to privacy attacks. It employs various techniques, including differential privacy, regularization, and adversarial training. We also have the drift detector, which provides data drift at runtime by monitoring a certain user-defined metric and taking track of the accuracy of a production AI model, which is continuously evaluated by monitoring this user-defined metric. We also have SGDE, which allows to access synthetic datasets in cross-silo federations by exchanging data generators. And this is a subset of all the components in the AI-SPRINT runtime environment. If you want to know further information about this, I will kindly ask you to check the AI-SPRINT website and also the public deliverables available, which provide further technical information. Thank you very much for your attention. Bye-bye.